Okay, so you're about to take the moles to moles quiz, and you've already learned how to balance equations. So when you see these coefficients here, this 1 and this 3 and this 2, you know that it takes 1 nitrogen molecule and 3 hydrogen molecules to make 2 of these ammonia molecules. So up to this point, using fractions for these coefficients was a no-no. You were not allowed to use fractions. Why were you not allowed to use fractions? Because if you said instead of a 2 here, if you said that was just a 1, then now things don't match up on either side. And if that became a 1, then that would make this a half. And if you're talking about a particle of nitrogen gas, N2, that's diatomic. Half of that would just be N. So that's just a free nitrogen atom. And that's definitely not what we're talking about. So up to this point, you haven't been able to use fractions. And I would say the reason why is because we were thinking of these things. We were just thinking of these participants here as single particles. All right, so we're talking about, 1 of these N2 particles, 3 of these H2 particles, and 2 of these NH3 particles. But what if we use some different unit? We're not married to just particles. We could say, instead of particles, we could say dozen if we wanted to. And I mentioned this in a different video, but you could say that 1 dozen of these combines with 3 dozen of these to make 2 dozens of those. Dozens? Dozen. Anyway, now you could use fractions. You could say that a half a dozen of these combines with 1.5 dozen of these to make 1 dozen of those. So if you're not talking about single particles anymore, then yeah, you could use fractions. And stepping up from dozens, we could actually use the unit that we use to count things in chemistry, which is the mole. So we could say that 1 mole of nitrogen molecules combines with 3 moles of hydrogen molecules to make 2 moles of ammonia. So where does that put us now? That puts us in a place where we can make up problems like, what if I have 2.5 moles of nitrogen, and I want to know how much of the ammonia, how much of the NH3 am I going to get? How many moles am I going to get? Well, your common sense math brain might be screaming at you right now saying, oh, okay, so if this is a 1 to 2 ratio, then if I've got 2.5 moles of nitrogen, then I ought to make 5 moles of ammonia. And that is correct. Your common sense brain did not lie to you. But I want to show you kind of a throwback to the first semester. If you remember the first semester, what was one of the early quizzes like this one? Learning dimensional analysis. You're converting things from, what was this video? This video was, I was doing miles per hour to meters per second. So we were learning how to do dimensional analysis back in September or whenever you did this quiz. So what I want to do now is I want to extend this to what we're talking about with this chemical equation here. So what I want to do now is, I hope I don't mess up your brain, but I want to explain what I'm doing. This equation is balanced. You know that you spent the time balancing it. You've already passed that quiz. So what I'm going to kind of do here is I'm going to say that instead of this being a plus sign, I'm going to say that's kind of like an equal sign. Or maybe I should use one of those kind of equal signs. I don't know. I'm just going to say equals. And instead of the arrow here, I'm going to also say that that's an equal sign. So when you have a balanced equation, these 3 things all go together in these proportions. What that allows us to do is that allows us to make the very important conversion factor. Okay, I've heard other chemistry textbooks talk about it as the mole bridge or whatever, but this is how I think I wish my chemistry teacher would have explained it to me in school. So what I can do then is I can look at this equation and I can say, oh, okay, so 1 mole of nitrogen in this balanced equation is equivalent to 3 moles of hydrogen gas, and it's also equivalent to 2 moles of this ammonia, this NH3 stuff. So remember, even though I kind of got rid of the plus sign and the arrow here, they're still there. I'm just kind of using these equal signs as a construct to allow me to solve these problems super easily. So now let me go back to that problem that I made up a minute ago. What was it? It was like you got 2.5 moles of, let's say, nitrogen is what it was, right? And I want to convert that to the ammonia. So what I do then is I just set up myself a dimensional analysis problem, a fraction, and I want to cancel out moles of ammonia, and I wanted moles, I wanted to cancel out moles of nitrogen, I misspoke, and I wanted moles of ammonia, this NH3. So all I have to do then is I just have to go and get my coefficients. It was a 1 and a 2. So the NH3 was a 2 and the nitrogen was a 1. So what cancels out here is the moles of nitrogen cancel out, and we wind up with 2.5 times 2. That is 5 moles of ammonia, or NH3. Okay, so that's, once again, your common sense brain did that for you just fine. But what if I give you a problem where maybe you don't like decimals, or maybe you don't like fractions, like this? What if I said you've got 6.3 moles of hydrogen, and I want you to convert that to how many moles of ammonia am I going to get? Okay, so if I want to solve this problem, your common sense brain might have a little bit harder of a time. So now it's going to become more important for you to be able to do dimensional analysis. And thinking ahead to the next quiz that follows this quiz, you're going to not be able to do it unless you can do this dimensional analysis stuff. So anywho, let's solve this problem right here. I've got 6.3 moles of the hydrogen, and I want to cancel out moles of hydrogen, so I'm going to put that on the bottom. And one more time, I was trying to get to moles of the NH3. So I go and I look at my my coefficients here, and for the hydrogen it was a 3, and for the ammonia, ooh, poor color choice. You'd think I'd learned my lesson. I guess I'll just do it like that. So it was a 2. So I'm going to fill in for my NH3, I'm going to put in my 2, and for my hydrogen, I'm going to put in 3. So now it looks pretty easy, right? All I've got to do is go 6.3 times 2. I can handle that in my head. That's 12.6. And then I've got to divide that by 3. And that, I am not going to take my time to do that because I might mess it up. So I'm going to go, let's see, I'm going to go 12.6 divided by 3. And I get 4.2. Okay, so 4.2 what? 4.2, the moles of hydrogen canceled out, so it's going to be moles of ammonia, or NH3. So this is the best way to solve a moles to moles problem on that quiz. Best of luck to you.